Okay, we're getting 20 some attendees coming in. Thank you all for joining us. I'm Dale Dougherty, and we'll start in just a moment. Wait for a few others to get here. Welcome to Plan C Live, the Civic Responsive Makers program brought to you by Make Community. This is a series of programs we're doing on Tuesdays and Thursdays, 4 p.m. Pacific, 7 p.m. Eastern. And we are also scheduling in other hours to do Europe, usually in the morning. We've done Spain, and I think we have Germany coming up. Our last show was on the Montana mask, folks. Really interesting things. We've done profiles of makers in cities like Atlanta and Chicago. And this one we'll be talking about UVC light and just in general, the idea of decontamination solutions. So let's go ahead. I'll introduce the panel and then I'll drop the slides actually start with Dorothy because it is a week of making and I'd like her to say a few words about that. But our panelists today are Brad Halsey and Laura Cummings from Building Momentum. We have Akiba, who's with Hacker Farm, but talk about the Hygiena project from Japan. Carolyn Fisher and Joseph Potts, if I say that right, Joseph, with DeepLocal, and Marvin Weinberger and Ed Polkowski of Lightbox IR, and Andra Key, I think. Silicon Valley Robotics is working on a UV robot, a remote-controlled robot. So let me get out of the sharing mode here. And Dorothy, why don't you say a few words and welcome. Good to see you.
Hi, nice to see everyone again. Always happy to be here. This is the week of making. We're excited. So we're all doing a lot of making. We've been really head down making for the last few months, it seems like. I guess it's only been a month, but it feels like 2 months. Yeah. But as you know, the week of making is a week where we get to showcase what everybody's doing. And even though we're not able to really showcase our spaces in the same way that we normally do, we are certainly inviting everyone to share online what they're doing. So you can definitely head over to Nation of Makers, to our online calendar and put in your events for this week if you're having online events. You can also share with us photos and videos. If you can do that on our Facebook pages. You can do that by sending me, Dorothy at nationofmakers.us email with your photos. And then I also shared with you guys in past shows that we've been partnered with Game Genius to run a fundraiser that is going through the week of making. So if you're an organization that's looking to fundraise, Game Genius has partnered with us to set up fundraising pages for your spaces completely for free. And we can get those set up for you. So what I'm going to do is we have all of this in our newsletter. And if you're not a subscriber to our newsletter, I definitely encourage you to do so, but I'm going to stick in the chat here the link to our newsletter, which has all of this information and more, including that NomCon is coming up. So our annual convening is happening virtually. It will happen June 3rd through 6th, and it'll be a great opportunity to continue the conversation from virtually Maker Faire, which is happening next week. And so we encourage you to get your tickets. We have a special going for a week of making. Again, all that information's in that lovely newsletter link that I just threw into the chat, and we will certainly share it with you in other ways as well. But it's always a pleasure to be here, and I always look forward to celebrating all of you. So I'm going to stop talking so I can hear about UV decontamination.
Okay. Hey, well, just quickly, a reminder, we are organizing Virtually Maker Faire on Saturday, May 23rd, and it's an open program. You apply at makerfaire.com through Call for Makers, suggest a session like one of these. We'd love to see maker spaces and makers organize sessions using Zoom, Hangouts, whatever you want to do. Just let us know what the URL is, what you want to do. We're looking for projects, particularly COVID-19 related projects to showcase, but anything you're doing during this time, any kind of making is relevant. We're also looking for demos and workshops. So go to makerfaire.com and find out more. Okay, well, let's get started here. UVC, ultraviolet light. I've been learning a bit about it. Wrote originally Brad was my first article or so, and then recently Akiba was an article, and then other editors at Make helped to publish an article that Joseph had built a UVC light box, I believe. So we're going to talk about it. Brad, could you give us a little bit of the science behind decontamination? I mean, there's sterilization, disinfecting, and sanitization, and all these different words. They actually slightly mean something different. So can you give us a little background on that?
Yeah, and thanks for that, Dale. And yeah, we actually argue about this sometimes in our own shop. My CTO and I have had arguments about sanitizing and what the actual definitions mean. The way we look at it, is the way I think the CDC also looks at it too, which is the UVC light has an ability to kill completely versus something like a chemical wipe, where sometimes you'll get resistance to things like that. So in a sanitizing process, the idea is that you have 100% lethality of the organism, and then in some definitions, you actually have to remove anything that is organism related. So you have to, wipe it clean off the surface. So UVC is unique in that way, in that it actually, the photons will come in and hit and break up a bond in thiamine. And thiamine is one of the base pairs that is necessary for DNA replication through the RNA process. And when that happens, it dimerizes, so pops in half into, I think, cyclobutane or something like that. And so if you do enough of those things, you break enough of the rungs on the ladder, the virus tries to replace those rungs with some other rung, but eventually it catches up and the virus can't replicate and it dies, or it just stops replicating. Viruses are weird, right? They're not really alive, so they just stop being able to produce, and then you're good to go with that dead organism or that dead thing.
Okay, so can you talk a bit about how and Laurel, jump in here, how you guys have tried to apply this, and actually probably before that, talk about why it's valuable to decontaminate things.
Right. So we started seeing, like all you guys did on this panel, we started seeing all of these maker opportunities arise. People were trying to respond to the need. And one of the things that popped into our heads was, well, for one, what happens to all the homemade and maker-made PPE that shows up on the doorstep of hospitals? They're going to want a way to ensure that that's been sanitized. And we actually run, we have like a 30,000 square foot event and maker space here in Virginia. And we were like, well, how do we sanitize this place for all the things that we want to be doing? So Laurel built our first UV sanitizing robot. And the reason that was important, and all you guys know this too, is it's about flux, right? It's about a power density, a wavelength, and a time to get that organism, that thing dead. And to ensure you're doing that, instead of like using a wand where you might just quickly go over something or something like that, a robot can actually calculate that. We have these dosimeters that can feed that information back to the robot, and we can make the robot go at a certain speed with a certain amount of power, ensuring that you're doing the safe thing. So she built iteration 1, 2, and now is working on iteration 3 of a robot that will move around a room at a very slow speed to ensure that that flux is getting met. Laurel, do you want to talk a little bit about how you first went through that process and why that was important?
Yeah, I mean, the other half of the equation, right, is like, one, you can trust a robot's speed and accuracy, like on the scientific side of it. But the thing that we haven't really discussed yet is that humans can't be exposed to UVC light. There's an incredible amount of danger to humans to be exposed to that same kind of energy that hurts bacteria and viruses. It also could hurt your skin and your eyes and all those sorts of things. So by having an autonomous robot be able to execute that sanitization process, you're hopefully taking people out of the equation for the betterment. But with the robot process, we actually built the very first one in about a week, just shy of a week. I think it was like 5 days. It was like this kind of crazy, very maker, like plywood screwed together on these old tracks that we had from an old project leftover, and it works. It shows that the proof of concept was there, but only once we got to the second version, which we built again in the next week, were we able to actually start getting like these really nice iterations on the robot design and getting this to actually accurately go around a room, making sure it doesn't, wander off the taped path that it's got down. And now it's functioning as it really should.
Yeah, it turned your hair a weird color there too, Laurel. So that's the downside of UV light. It bleaches it yellow. And the team is set up that way. So my team has spent a lot of time on battlefields and disaster zones. So responding in a week was an exercise that wasn't crazy to think about. And so in 2 weeks, she actually went through 2 generations of robot. And then that spawned and kicked off a whole list of things. Like we realized you could make UVC conveyor belts. And we were doing those dosimeters to see if that was, if that was efficacious. So it just kept knocking rocks down the road.
A bit like an automated pizza machine.
Yeah, I mean,
baking,
pretty much.
Just kind of like putting in one end and getting out the other. But you did it. I mean, I kept seeing the food metaphors, but that might be me. The UVC grill looked like a backyard barbecue. I put that in the slide coming up, and a number of different containers. Because how long do you have to leave something in something like the room's a different problem. You're kind of cleaning an entire space, and you have to get all around it. But putting masks in a box or a grill, things like that. What are the different time frames?
Yeah, it really boils down to getting that flux. So we were shooting for something greater than 500 milliwatt seconds per square centimeter, which is basically greater than, or 500 millijoules per square centimeter, which is what the CDC has said is decent enough to sanitize an N95 mask. Although there's a lot of questions. We can get into all of that later if we want to. So how do you get that flux? In a UVC grill, like some of the ones we made where we just put a ton of bulbs together in a clamshell and just irradiated that thing, that can be achieved in tens of seconds. The nice thing about the conveyor systems that we built is that you can then drive the conveyor to meet that 500 millijoules in that process. And then you just flip it over and run it through again. And so we realized we wanted to take humans out of the loop as much as possible. So everything was designed to be safe. Obviously, the grill was not super safe if you opened it up while it was on. And turning those bulbs off, the ones that we were using, the low pressure mercury vapor ones, you really reduce life cycles and lifetime on those bulbs when you cycle them off like that. So we tried a system that kept them on at least as long as we could, and then controlled that flux rate. So a UV conveyor might take a minute to get through. A room might take an hour. And it's just, again, it's a function of getting that 500 millijoules per square centimeter.
Yeah. Akiba, actually, both you and Brad, I think, have experience in disaster response. Brad has been involved with hurricanes and going to, was it Virgin Islands? Brad, you wrote about it for us. And Akiba, I think, is really well known for the SafeCast project coming out of the Tokyo hackerspace. There I think was a case where the government really wasn't telling the citizens about the radiation levels, and so it was a group that came together, building DIY Geiger counters and taking them around the country and measuring and mapping what the radiation level was. But it's a really a distributed response that I think, once again, we're seeing it here. Akiba, welcome from Hacker Farm in Chiba Prefecture in Japan, right?
Yes. Hi everyone. So I got involved in UV light decontamination just because it was really hard to watch everything that was going on, and I didn't want to just it was hard to just sit inside while everything was going on. So I felt like what is the smallest thing that can be done? And so we started investigating the UV light decontamination. We did the Hygiena project, which is an open source decontamination project, and it's based around the protocol that was released by Nebraska Medicine, which is a hospital that dealt with the Ebola outbreak. They published their protocol publicly, and one of the things is we work with World Bank in a lot of developing countries, and also dealing with a lot of specific problems. And it's almost never about the tech. We realized it's almost never about the technology. It's about the people and the processes. And because Nebraska Medicine had already published a full protocol which defined the roles, the process, and also the devices needed in order to decontaminate masks, then we realized that it was pretty much like the main thing that would hold up hospitals from adopting something like decontamination would be they don't have the time to create the protocols around it. And so with since Nebraska had already created the protocol, then basically what we did was just try and emulate the devices inside in the protocol. So one of the UVC lights that they were using was from Chlorisys. It was called a torch and cost $25,000 per device. And within the protocol, it uses 2 devices. So it's like $50,000 in order to emulate their protocol. So that was an obvious area to tackle. And so the goal for the Hygiena project was to use off-the-shelf parts, like standard 2x4 lumber, compact, like fluorescent light fixtures, and also UVC fluorescent lights that fit into those fixtures. And the goal was to have the light sources and the dosimeters for around $100, which is like around $100 in materials, which means that it would be like it would be possible for not just hospitals to have a decontamination system, but also places where I think essential workers are, like grocery stores, break rooms, things like that. And I think, and that's one area that's really overlooked, but in need of things like decontamination.
So explain what a dosimeter is.
Yeah. So one of the things we built was a dosimeter, which is and Brad was referring to it in terms of flux. So when you have the UVC, or I should start with like the CDC and the National Institute of Health, they put out like studies in how much dosage of UV light is required in order to inactivate a virus or a bacteria, et cetera, et cetera. And so like the virus inactivation isn't based on the intensity of the light. It's based on the dosage, which is basically like how long it's exposed, how long it's exposed to the light, of a certain intensity. And so like, so you don't necessarily need a super strong source, but you need to make sure that the whatever surface you're decontaminating is exposed for the correct amount of time, or has a certain amount of dosage. And so you can actually measure that dosage using what's called a dosimeter. So one of the main things that we developed was a dosimeter to measure that. And so it was using a low-cost UVA sensor, which is available on like from Adafruit, from Amazon. But it was also sensitive to the UVC band. And I wrote it up on the Hacker Farm website, but basically using that sensor, you're able to measure, the amount of UVC light and also the dosage of the surface that you're trying to decontaminate. And that will tell you quantitatively whether or not you're reaching the CDC guidelines, as Brad had mentioned. So, and that was and that's an important thing, because otherwise you just be kind of guessing, and you don't really want to guess in something like this.
Great, thank you, Kevin. Let's go on to DeepLocal. Carolyn, could you explain what DeepLocal is and where are you right now?
I would love to explain that. I'm going to derail us very, very quickly from UVC to talk a little bit about DeepLocal, but I promise it's all relevant to the invention that Joseph will share following my little spiel. I actually have some images. I'm going to go ahead and present to the meeting. Is that working for everyone?
Yeah.
Okay,
Yes.
great. Wonderful. So very, very quickly going to walk through a little bit about us. I think are kindred spirits with all of the panelists here, but we come from a slightly more lighthearted, I guess, background. We are creative engineers like everyone. The makeup of our company is about half engineers of different disciplines and then half creatives of different disciplines. So we have a lot of people with industrial design and environmental design backgrounds. We're actually a spinoff of a research lab at Carnegie Mellon University here in Pittsburgh, which is where we are hailing from. And we kind of fell into this industry of inventing tangible interactive experiences that tell human stories. So we actually partner with brands. Our main client is Google, to create experiences that live in the physical world, that are tangible, interactive, and use technology in creative ways, and are usually pretty delightful and shareable as well. So I have some super quick examples in here. This is called the Chalkbot. We built this for Nike, and it's essentially a robot that chalks tweets on the street, and you can send your message to the robot, and it uses these custom chalk nozzles like a dot matrix printer to print your message on the route of the Tour de France. And this is a roller coaster that we built for CES last year that demoed some of the new Google Assistant features. So this is the type of work that we usually do. Again, we have sort of a full stack process that we keep under one roof. We have creatives, engineers, strategists and producers, as well as fabricators and install. Similar to Brad, we have a very large rapid prototyping facility and fabrication space that has everything you would ever need. So usually our work looks like this. But of course, when the pandemic hit and we had to close our shop, it started to look a lot more like this. And we also began to have lots of free time, as you can guess, because much of our work is devoted to coming up with real world installations that are going to be seen at events like South by Southwest, the Olympics, trade shows, and all of these things are being canceled and postponed. We also had a genuine desire to help. We come from, again, Pittsburgh, which is a city with a lot of prominent healthcare companies out there. There's been a lot of research done at UPMC for COVID-19. So we suddenly had this remote creative engineering workforce. We had hours, we had skills. So we came up with this project that we call Cabin Fever. And basically the goal of this was to take all of our resources and our talent and devote it towards maker projects that can help provide solutions, or sometimes just a little bit of joy and escapism and humor. So some of the work that we've done under this includes a smart soap dispenser called Scrubber that could be used to time hand washing. So when you press down on the pump, it actually uses your Spotify API to play 20 seconds of a top track. So you can, instead of singing happy birthday, listen to a favorite song. We created this Chrome extension called Face Off. That's like a hygiene battle royale that docks points every time you touch your face on a Google Hangout. We created this website, very simple website in the lower right-hand corner called 6 Foot.
It's not active now, is it, Caroline?
I don't think so. This was really a 5-minute project.
I don't want to get docked.
Yeah, no, Face Off. No, you have to have the extension installed. So, okay. And it's actually, we're still working on the Zoom compatibility, but it is fully functional on Google Meet. So. We did 6 Foot Zone, which is, if you can read this, you're too close to me, which was just a simple measurement of how far someone was away from your screen. And then finally, one of our greatest triumphs has been this UV, which is what we're calling our version of the DIY UV irradiation cabinet. This is a brainchild of a lot of people, but essentially, and I'll pass it off to Joseph to talk more about this, but essentially our aim is what a lot of people have already said on this panel, that we wanted something accessible. We wanted something that people could do who didn't have specialized skills and tools or infinite budgets to spend on this. And we challenged a bunch of our engineers and designers to come up with a design that was feasible under those parameters. So that's my little setup for Joseph, but he's really one of the brilliant minds behind this design. So I'll pass it off to him.
Hi, Joseph.
Hey, yeah, thanks, Caroline. Yeah, so I'm just gonna bring up the Make article because it's easier to do things with visual aids. But so
I put a link in the chat to Joseph's article on MakeScene.
Yeah, so UV is a UV irradiation chamber. Like Caroline said, it's designed to be accessible. So we were looking at we were inspired by a lot of the other maker UV chambers, but we were having trouble sourcing a lot of the parts because Amazon has longer lead times for some of these specialized UV parts. So we were trying to figure out how can we do this in a way that has easy to source materials and is also accessible to non-makers. So no complex fabrication methods, no wiring. And we kind of took this approach primarily because a lot of the people at DeepLocal have friends and family who work as nurses or at police stations or fire stations. And they were saying like, hey, we really like a way to decontaminate our masks, but we don't have any good way to do it. And they're also not makers, so they're not comfortable with more advanced fabrication techniques. So we kind of took this challenge. And there were about 3 or 4 of us who each we did it kind of hackathon style. So like we had a couple days where we each tried to source parts, come up with designs. And like some people were using like disposable aluminum, like turkey pans. Someone was using a toolbox, and I ended up going just a plastic bin. So, you know, plastic bin, work light, UV bulb. It's a pretty simple setup. And so the actual kind of process of making it, there's a standard fluorescent work light that is built around. We were able to verify that the UV bulb that we got works with this lamp. We just had to do a couple, you know, mechanical adjustments to get it to actually fit. The bulb itself is actually from like pond sanitizer. So in a pond that you might have in landscaping, you don't want to get algae buildup. And so there are a lot of UV devices that'll kill that algae essentially using the UVC radiation. So that means that it's an easily accessible part at a place like Lowe's. So that's how we got the bulb. And then really it's just, you know, cover the box in foil tape, which is honestly the most time consuming part of the process and also the most fun. I thought attach the work light to the lid with some zip ties and then put on some finishing touches. And one of those I think is really important and is probably my favorite part of the project, which is this kind of DIY safety interlock. So most UV chambers, people mentioned earlier, like UV is great at killing viruses and bacteria, but because that you really don't want to like be exposed to it on your skin or your eyes. So most chambers will have a switch that when you open the lid, it'll cut power to the light immediately so that it doesn't there's no way that you can open it and be exposed. So we wanted to make sure that we had a similar feature on the box that we built so that this couldn't cause more harm than good. But actually using a switch and plugging it into the power line would likely require wiring. It means sourcing a more complex part. And so what we were able to come up with after several different iterations was this safety interlock where, since the box actually has 2 latches on the sides, we were able to zip tie the power cord from the light, which is the black cord, and just a standard extension cord, which is the green cord. We were able to zip tie those to each of the latches and then plug it into the center. And then you really can't, it's actually, I was surprised how well it worked. You can't open those latches at all when it's plugged in. And then also it's right on the middle of the top of the box. So it's also kind of like a visual reminder of, hey, you need to unplug this. So that was I think a big win we were able to come up with is like, yes, we have a way that makes this safe. So you can't have an accidental exposure to the UVC. And then also we added in a little paint grate in there to raise the item off the base of the box. So then you could actually get the UVC light bouncing off the base and hitting the underside a little bit. Not enough to fully decontaminate it, but it still kind of helps keep the light in the box from dissipating. And then finally, during the process of building it, we were actually also able to get a UVC meter to test that, a dosimeter to test the test the actual intensity of UVC light we were getting in different parts of the box, which was a lot of fun. And also, as other people mentioned, we wanted to make sure that this was safe and that it was actually doing what we thought it was doing.
Oh, that's great. Thank you, Joseph. Let's see. Let's go to Marvin and Ed. I think Ed may have scrolled off here, but no, there you are. Ed,
Oh, I'm
sorry.
still here.
There you are. Marvin, welcome from, I guess it's Havertown, but I said Philadelphia more generally. You've been involved with the Maker Faire in Philadelphia, and it's good to see you. You're an inventor, among many other things. Tell us, so the headline that was in your local paper was you were creating a sterilization a unit for masks using a pretzel warmer, which you have a different approach, which is more an oven that the pathogens can be removed with heat. So welcome, Marvin.
It's very nice to meet all of you. I'm impressed and excited to have a chance to present our simple idea. Our Philly team of volunteers started with the goal to create a simple, durable, safe, and reliable do-it-yourself mask sterilizer with high throughput, built from readily available, inexpensive off-the-shelf parts. Of course, we didn't want to involve dangerous chemicals nor require any programming. And more specifically, the spec we set for ourselves was to process at least 50 to 100 masks at a single time with a duty cycle not to exceed 1 hour, all within a small and easily transportable cabinet of about 1.5 cubic feet. As Einstein said, your design should be as simple as possible, but no simpler. As you'll hear, we think we've come up with something that's quite simple, but as Ed will point out, there are some interesting twists. We first considered UV LEDs, and I note LEDs as versus lamps because we were concerned about durability and duty cycles. But we were only looking at medical grade components, and they were rare, and they were also very expensive. But most importantly, we quickly discovered that while UVC is a very effective way to kill the organism, you have to bathe all mask surfaces consistently in the light, which limited the number of masks we could accommodate in a short duty cycle within a small cabinet. So we pivoted, like any good entrepreneurs. Instead of Lightbox UV, we became Lightbox IR, which borrows from the design heritage of a countertop pretzel warmer. As it happens, the virus has an Achilles heel when it comes to heat. Research has shown that the virus can be killed by exposure to relatively moderate heat of just 165 degrees Fahrenheit, as long as you're able to maintain that for roughly 30 minutes. With design and engineering from my volunteers, including Ed Polkowski, who you'll hear from in a moment, and Evan Gerge, we built a prototype which is undergoing thermal testing, and once perfected, will be tested in a lab at UPenn using masks inoculated with a biosimilar organism to prove the Lightbox will reliably kill the virus. As Ed will explain in a moment, the hard part was how to achieve consistent heat with a short ramp time of no more than a half hour for the cabinet and all contents, with the intent to bathe all surfaces at 165 degrees for 30 minutes without causing scorching or hot spots, and even when densely packed. Again, 50 to 100 masks within this small area. Moreover, the temperature has to be maintained within an exacting window. We don't want to exceed 180 degrees Fahrenheit in order to minimize mass degradation. In addition to Ed and Evan, our team includes Bruce Wilner, organizer of the Philadelphia Maker Faire, and Dr. Basil Harris. Dr. Harris, who Dale knows, is the winner of the $10 million X Prize for his real-world tricorder. You should really check it out. We were also receiving technical support from the Lasco Products Company, represented by our friend John Harrington, their technical VP, who's also listening in this evening. Lasco, a major international company, is considering creation of a commercial unit based on our work, which they would sell for the immediate future at basically just above cost. working with volunteers in their factory. The current build cost with all parts ordered at retail from Amazon for our DIY model is around $160. But with a target capacity to sterilize 50 to 100 masks an hour, we believe the light box at $160 an hour will pay for itself within probably no more than a week or two, given the current cost of masks. Of course, most importantly, we hope our device will save lives. I welcome everyone's comments and collaboration. Just email me. We don't have a website yet, but you can email me, marvin@innovationfactory.com. And I'd love to hear from institutions which would be interested in obtaining the light box. And now, Ed, take it away.
Sure, yes. I put together a short presentation. I finished it, I think, 2 minutes before this started. And we'll get that going.
It's amazing. Everybody has experience in Zoom these days. So they're a lot better at it than they were a couple of months ago.
Okay. Yeah, I never even knew how to share screens 3 months ago. That's all we did was share faces. Okay, let's go to the beginning here. So as Marvin said, we originally looked at UV, and when we started looking at sourcing the parts, the LEDs for the shorter wavelengths were quite expensive, anywhere from like $12 to $20 to $30 each. And we were looking at placing at least several of them within the box. So I purchased a couple to do a prototype assembly. And after I bought that batch, they were no longer available. I think it was either DigiKey or Arrow. They got cleaned out. Everybody got cleaned out from UVC LEDs. So it's impossible to find them now. And certainly, not enough to do multiple projects with. And we shifted from one end of the spectrum, from the UV over towards the other end, and started looking at the heat. So we're using actually just a regular light bulb, and one that's 200 watts and possibly a 250 watt. So it's working kind of like an easy bake oven. If any of you had kids, girls that were growing up and bought the little oven with the 40 watt light bulb in it that used to bake things. This is exactly the same process. And I'll show you a little bit later the prototypes that we put together. As Marvin was saying, he was able to pull together a whole group of volunteers and partners on this project. And Evan is one of the guys that built a prototype. My background is I'm an electrical engineer, and I do a lot of hands-on stuff, but we had two of the other guys here, Evan and Eric Wagner. Eric was someone that was involved also earlier in the project. Each of those guys built a separate prototype, which I'll talk to a little bit and show you the pictures of it. And both of them run well. And in addition to the prototypes, we have Lasco products involved, which actually supplied a whole bunch of masks for us to load up into the system to test out. And just got those today. They arrived FedEx. And tomorrow I'll be placing those in our unit to actually do a test run with temperature monitoring. This way we can verify that the stacks of masks actually reach the proper temperature throughout the entire stack and exactly what kind of cycle time we need to run that with. So some of the other partners that are involved here are BioRealize, which is going to be helping us do the actual validation testing of killing bacteria and viruses. So they're in a position to be able to do some testing with the unit once we validate that it hits the right temperatures. We're going to expose some masks and swab them and put them through the unit, and then do some growths from that later to determine whether the bacteria and viruses used for the test, I think it's going to be bacteria for this initial test, actually are deactivated by the heat. And as Marvin mentioned, Lankenau Hospital is also involved as a potential site. They have expressed an interest in actually.
Ed, can you move along a little more quickly there, because I
sure. So what we'll do here is we'll skip to the design requirements, and it's the same as Joseph mentioned earlier. It can be built by DIY people, all off-the-shelf parts. And it has to have been tested and shown effective in killing coronavirus. So some of the design constraints that we looked at are the radiative versus convective heating, touch safety for the various elements, the combustibility of the materials being used, and protection of the bulb. So we also looked at the controls on here and found some very simple ones that were used for fish tanks and aquariums that are available off the shelf rather than building something a little bit more complicated. And of course, it's a simple control, so it does require a bit more monitoring than some of the others would if you were to automate it. And here we have the pictures from Eric's build and from Evan's build. And you can see they look very similar. They're sized about the same. Eric actually put a heat lamp in from the bottom, and I think this one actually shows a regular bulb in here now, whereas the bulb is on the top end in Evan's design. So Evan's design is the one that I'm working with currently. I have it in my garage, and I'll be doing the testing tomorrow. So of course, no project is complete without throwing an Arduino in there somewhere. So this is a monitoring circuit that I just put together over the last 2 days. My probes finally came in, and it's a data logger that's going to be able to measure the temperature at 6 different points within the unit. Actually 5, one of them will be outside to measure the environment temperature. Yeah. And this will verify that we're actually getting up to temperature in the mask stacks, and that we're not overheating, causing damage to any of the elastic materials or filtering materials in the masks themselves. So the next step is the validation, and that's where we're going to have BioRealize involved and possibly the hospital that can also run some testing for us. Okay.
Great. Thank you, Ed. You know, one of the things I'm really glad to see, and for maybe makers in the audience out here, I particularly learned this from Akibo, just watching his project, but it wasn't just about building the thing. It's about creating a framework for testing it to make sure it really works. Because, you know, and it's a little bit different, but almost all the PPE, almost the things you really needed to test. And some of the makers have really struggled with finding ways to affordably test the things that they're making to know that they work. Well, let's move on to our last panelist, Andra Key, and welcome. Andre's with Silicon Valley Robotics, and you know, you're working a little bit in the helpful engineering group, is it? I believe. And tell us a bit what you're up to.
Okay, well, it's a pleasure being here, and I've been taking notes because everybody's a lot further along in some regards than we are with our project, but my day job usually is looking after robotics companies and startups. Silicon Valley Robotics is a non-profit industry association. So we have some, for example, robotic startups that are now actually building decontamination robots. Although I'm trying to get the details on exactly what they're using, it looks like they may be going in for fogging and misting rather than for UVC.
Andra, can I interrupt you for just a minute? Are you folks seeing Andra? Or are you seeing the presentation? I think we need to have Ed exit the share screen if we can.
Okay, yeah. Let's see. Well, I know how to turn it on. I apparently don't know how to turn it off.
Just up at the top of the screen, there should be a red thing that says stop.
Yeah, there's just a red button there.
Okay. Okay, I'm gonna force it this way. I think that'll.
Okay.
You get it?
Let's see if you can turn that off.
Okay. Sorry.
It's possible to request remote control of Ed's screen. I've just given that a go. Click to start. Oh, and now Dale's screen.
Okay.
You've done it.
There. Okay. That got him out of there. Now I'll stop. Okay. Sorry for the interruption. Both the audience and Andra particularly. Continue.
Okay. Well, so in my day job, I'm helping startups like OmniLabs, who are doing telepresence for hospitals, and Ubiquity Robotics, who are doing a disinfecting robot although as said, I believe they're using a fogging technique or technology rather than using UVC or pulsed xenon, which is what one of the other US-based commercial decontamination robots is using. But it can be really frustrating just working with robot startups. So on the weekend, I'm working with groups at Circuit Launch, which is currently closed except for essential work. But it's one of the several factory makerspaces around the Bay Area where we've set up safe workshops. And there are various projects ranging from McCrafties, Distill My Heart mask making, to an oxygen group, to a ventilator group, to the PPE groups that I've been involved with. So I initially started on the weekend building the origami face shield, which was primarily laser cut of PET, because I think I'm probably like every maker. I started 3D printing things, and then I did a little bit more research, and I realized that 3D printing is really one of the least effective materials you could possibly have. It takes terribly long to make anything, and it is not hygienic effectively, even with the research done into sort of silver infused filaments and some of the other threads that go on there. There are really a lot of people making things that were 3D printed that weren't going to pass the test when they went to a health facility. And I think it's really important, as you were just saying, Dale, the ability to test things and validate where they can be used is really critical. And it was a little disconcerting to see a lot of things being spread on the internet that were designs that were not good. For example, the Prusa face shield design was originally intended to be worn over people wearing goggles. And so it has gaps. And if anybody who's not wearing goggles wears that face shield, they're not protected. And that information didn't necessarily transmit.
Well, that's it. If I just, that's what I love. Akiba bringing in protocols. In other words, it's a set of things you have to do to be safe. It isn't just one thing. So it's overlapping devices sometimes, like a mask and goggles and a shield that we see there. So
and the best projects I'm involved with are like All Bay Area PPE and open source COVID medical supplies and helpful engineering. They have enlisted people with testing skills, quality assurance engineers, and they've partnered with healthcare professionals so that they can get that feedback. And in fact, one of the first things I was doing was, I'm a visiting scholar at UC Berkeley, and I was suggesting that instead of turning their makerspaces over to creating things to support labs, although that was still important, their ability to validate and test would be something that was really critically essential. And since then, actually, the NIH has been producing a directory or database of 3D printed objects with or without validation. So that's
but if I might interject, they're not really clear what their criteria is, and they're not actually doing the testing. And if it's a laser cut solution versus the 3D printed solution, it doesn't belong in the set. So it's kind of a curious
I found it was really messy and disorganized, especially given that it shows you everything. So it's really easy to assume that if you're on the NIH site, any design you get is therefore good. And I love, sometimes I describe myself as a human systems engineer, because it's that human in the process that is really the starting point of all of this. And it's also the point of failure, but it can be the point of advantage if we take care of always putting the human in the loop. So I'm very much about not just user-centered design, but human in the loop design. And now I'm going to dare to share screen and see if I can. I've got 3 slides, if I can find them. Here we go. Okay, so this was what I was starting on working. We had a couple of laser cutters going night and day, and I was cutting up rolls of PET to make face shields. And while we were doing that, I think you can see the crossover band at the back. I was also looking at other things. It turns out mask extenders or ear savers are really in demand, and I needed one. So I had a lot of broken headbands. And I just taped a couple of sides of that together and started using that as a mask extender for myself. And I realized that it was far simpler for us to laser cut mask extenders out of PET. So I adapted the Helpful Engineering's origami face shield design so that we now have 6-inch, 9-inch, and 12-inch mask extenders or ear savers out of that. And I'm hoping that the plan will get disseminated with the face shield plan, because one of the key things is it might be fun redesigning things over and over again for some of us, but there are many others of us who would just prefer to find something that works and get going. And I'm really interested to see a lot of this innovation, I think, is definitely creeping into the commercial way we do things. We are going to be using 3D printed nasopharyngeal swabs in future because they're cheaper and better. We're going to be using more of these PET face shields and hopefully mask extenders because they're cheaper and better. And nobody was really interested in innovating around something in the way that we are now. But that leads to, we got excited about the idea of another project, and I'm trying to move my slides forward, doing a disinfecting robot. Because right now you can see to have a manual UVC disinfecting tower is $26,000 on special at the moment. And that's a manual one. You move it into place. And then to have a robot one, for example, the price of the Xenix ones, and they are using pulsed xenon rather than UVC, but it's a similar effect. They're around 125,000 USD. And most of the others are no cheaper than $75,000. And of course, how is that going to scale up and how is that going to be available for people? So we had an idea. It's a mobile robot chassis, which kind of equals a Barbie ride-on car. It's a lighting tower, which if we work on affordable, available, off-the-shelf components, hopefully we can reduce the price of that. And a friend of mine who founded Remo TV has created a teleoperation site that is super simple to connect your device to it and have it teleoperated anywhere in the world really efficiently. That's Remo TV. So if we put all three of those things together, the goal is for $500, we have a remote operated UV robot. I can't really call it a robot when it's remote operated, but we were thinking about having some autonomy in, say, fail safes and safety things like sensing people in the room and so on. I think that it will have to be controlled by healthcare workers themselves rather than being left to the public, but it's hard to, I think citizen science has generated so many wonderful results. It could be really cool to have some of these being driven by people who are doing it for fun, well, for the enjoyment of being able to do something positive. Some suggestions were retired health workers, for example, but I've been doing citizen science for quite a while, and it's remarkable how keen we are to donate our time for constructive things. Another of those projects, just leaping wildly sideways, is of course the Folding at Home project, which is modeling the COVID protein. And now users at home who are contributing their Raspberry Pis to the Folded Home project have created the world's greatest supercomputer. So that's the positive power of the citizen response there. And we want to harness that.
Okay. Thank you, Andrea. Good. Well, I want to point out to you, if you're in the audience, there's some really excellent Q&A. Thank you, Akiba, Marvin, Brad, for answering that. Also in the chat, there's a separate Q&A section down there. We don't have any open questions there because so many people gave smart answers to it already. That's in the past. But, if there are any, we have a few minutes here if there's any questions. But let me summarize a couple of them, and maybe if you don't mind summarizing your answer a little bit. People are wondering about the effect of UVC light on 3D printed objects. Akiba, do you want to address that as you did?
Yeah, I think like UVC isn't the greatest for 3D printed objects because it's not a completely smooth surface. There's a lot of crags and like kind of nooks and crannies. And so something actually like a chemical solvent, like a bleach solution or something, might actually be better in order to disinfect it. Like UVC, I think, is good for room decontamination, and it's used by some hospitals for the mass decontamination as well. But I think it doesn't work well on non-smooth surfaces.
Right. I mean, do you think we'll see UVC like we see large vacuum, like floor cleaners in hospitals, just sort of moving slowly down hallways, doing disinfecting like that?
We better not be seeing them because they're too close.
Yeah,
that's the real key thing.
But I mean, it's kind of the Zamboni of UVCs.
The commercial interest is huge. I mean, the companies that are producing robots to do this are getting through the roof demand. They can't keep up.
Laura, what is your use case around a robot?
Well, with robotics, like I said, removing that human element and the risk of exposure to UVC light is crucial because you want to keep as many people, at home and away from any issues as possible. The teleoperating, we came to the same conclusions. We built that functionality into our robots as well. But with robots, you can really make sure that you're hitting the crucial areas. One of the things that we kept talking about in the office as we were going through our kind of design process for our first version of the robot, sorry, that's my cat, was talking about what are your critical areas, right? You're not going to be touching the roof of a building as much as you are, say, something at 6-year-old hand height, right? 6-year-olds want to touch every single thing within reach. And so maybe those are the areas that you want to be focusing on. And so with robotic design, you can kind of concentrate on those areas without having to worry about missing out on any other aspects.
Okay, good.
I actually had a question, Dale.
Go, Dorothy.
So I think one of the things that's been coming up is the uneven surfaces and how do we deal with uneven surfaces. And earlier today, I was on a Zoom call with the library's maker group, working group for the Nation of Makers. And one question they had was, how do you decontaminate VR glasses? Because a lot of them have invested in VR systems, and that's one of the most popular sort of things they have in their particular makerspace. And there's a huge concern that they've invested all this money, and now when everyone starts to re-enter, even though we may have sort of social distancing, there are some sort of tools and things that we use, and I've also heard this from ophthalmologists and optometrists and people that use equipment that has the human's face touching it. How do we do a good job of that? And I guess I just had a question because I know that there was some chat in the chat about how do we deal with uneven surfaces? Have you guys come up with any sort of suggestions or thoughts, either without UV, or I know UV may not be the most suitable in that particular case, but I'm curious what people have seen out there.
Well, Dorothy, I can jump in on one of these. We're looking at that right now with the Navy. The Navy's asked us to start thinking about how to decontaminate pallets. And as you guys know, Battelle made that hydrogen peroxide system, but those are also $7 million a piece. So we're like, can we
get it down to 10 million?
Right? I mean, it's sort of like, I like Ed's approach of just like heat it up. Anyway, so we're looking at that. It's actually brought up two really good points. One is we're developing a system in a shipping container that can hit it with blasts of air and try to knock loose particles that might have virus on it, and we're adding ozone decontamination. The other question, and I've been on a bunch of panels discussing this, is do you really give a crap about all the surfaces? Like maybe you don't, and in fact, maybe you want to drive people to touching certain surfaces that are very reproducible. So you think about like a pallet, right? So some people argue with me, well, how do you know you're not getting the underside nook and cranny of a pallet? And my argument is, how do you know you're getting COVID there? Like COVID doesn't go there on its own. It's not like it's going to vacation under a pallet. It's got to be put there by, coughing or some weird way. And so I think uneven surfaces can be made more predictable. And are there ways to touch or interact with surfaces, like if it's touching your face, can you make that surface more predictable? And then just sanitize the heck out of that and stop, some of these electronics, they can't survive liquids and can't survive these types of things. And what Akiba was putting in the chat there is people are asking about, opaque systems and opaque things. And yeah, it's a surface decontamination thing, but we can also think about ways to make the surface better. And that's, I think, a human factors design problem that might go on. One of the things that I was hoping that we could maybe get into in this discussion is what happens next? What's the future going to bring? What are we going to do to modify things, not just react, but think through and predict? And I think that's one of those areas, Dorothy, that we should be thinking about is how do you predict surface touching?
And I think actually probably some great, people have done some of that research and included some of the surfaces, maybe not all of the surfaces that we can predict, but I think, that's definitely work that's done. And that's actually a really interesting way to turn it on its head, which I know you guys are very familiar with doing. So that's really awesome. And I wouldn't be surprised that you guys are thinking of that in that way.
Yeah.
I think that's excellent.
There's also work being done, for example, in fusing copper or silver or in other ways modifying the surfaces. I've even seen some sort of processes where they basically create certain types of ridges on the surface where bioorganisms just don't like them and can't live on them because they're on their level, they're jagged, that you can't feel them on the human level. So I think you're going to see a lot of this beginning to happen.
So we have one, Skip Pope is someone in the audience who wanted to ask a question in person. Skip, do you want to unmute yourself and ask your question or make a comment?
No, sorry, I hit the raise hand by mistake there.
Oh, that's okay. All right. Well, we all learning here. Well, we got to hear a voice. Andrea, did you want to come in?
Yes, actually, another startup at Circuit Launch, Fathom, is doing ozone cleaning. And they were originally aiming at just being a little home cabinet because it's very affordable that you would put your dirty sports equipment in and things like that. But they are repurposing and they're trying to get the testing validation needed to show that they're good for masks. But I'm just thinking the idea of libraries with shared AR, VR. I love the idea. This is a technique for sterilizing that would deal with electronics. So
one question that came up and I think it was answered, but I think it's good to repeat in case people didn't see it, is does decontamination or sanitization of mask, does it change, particularly a 95 mask, does it degrade the mask material in any way?
Yes. Officially, there's only an accepted number of times a mask can be cleansed. And that probably depends on the facility. I think part of the Battelle, for example, is certified to re-clean masks for a finite number of times. It's somewhere between 5 and 10.
Yeah, Kiba?
I think I think N95 Decon was actually kind of came together. The website decon.org has come together in order to answer questions about the different N95 sterilization techniques. But generally, I think with UVC I believe it was 3 times. But the thing is that the mechanical fit actually wears out very, very quickly as well, because N95 masks weren't originally meant to be reused. But it's best to go with the scientific studies, and you can find those at n95decon.org. I think there's a link in the chat.
Yeah, great.
From the research that I've come across and some of the experts I've consulted, and we've talked to a lot of people, particularly with an N95 mask, the issue is not the non-woven material. That's made of a plastic which actually has a pretty high melting point, as I understand. It's that some N95 masks actually have paper components, and of course, many of them have elastics, and those are a little more sensitive. Also, regarding ozone, the original light box actually started with ozone. We were in touch with some companies in China that were going to rapid prototype, but then we talked to some health experts, and there are some real issues, particularly in the hands of consumers when it comes to ozone, that if the boxes are open too soon and the ozone doesn't dissipate, that can be a real health risk. So we actually looked at a lot of different approaches to including, for example, moist heat, which is also effective. But then you have to have a source of water, and then how do you keep it clean? What if the water gets contaminated? So that's why the dry heat.
Yeah. Well, we're past the hour here. I want to thank everybody, but I also want to thank you for your work. One of the things that we've been covering is just these DIY sort of open source, low cost solutions. We're seeing the need for things that are maybe really expensive and industrial and exist in a few places to be in lots of places. And really that's what I think what Akiba's looking at isn't just, solving for the hospital that might be, say, Mass General, but the developing world, lots of places that can't afford decontamination units, and to make those, something that goes from, say, $25,000 down to a couple $100, even if it's a DIY solution, I think is a real form of innovation. It's putting technology in the hands of more people in more places, and I think it's an important thing. And many of you are doing that. Joseph, your box is giving people a way to do something that they might not know. So thank you all for your work. And Brad, we'll have to kind of maybe reconnect somewhere down the road and talk about that future idea. Where does this go? But I think I actually think there's going to be an interesting long life to a lot of the innovation that's coming out today. That's not just, it might, quote, move on from PPE, but both the processes, the people, and the ideas, I think, will be remixed together down the road. And thank you for mixing together today on this program. And I hope to see you all in another setting. Thank you very much.
Everyone, happy week of making.
Thanks,
Thank you all
everyone.
for attending. Bye-bye.
Everybody.